that?
Um, wouldn't U be X?
So you have to be able to take a derivative, but you can take a derivative of both, and you have to be able to integrate the other one. You can actually integrate both. But the reason this is correct is because when you take the derivative, it drops the degree down by one, and it then makes it possible to then find. So you're right. dv is sine x dx. du is 1 dx, and v is minus cosine x. So do you remember the formula for integration by parts?
Wait. Um, it was like U, what was it?
So
UV.
uv minus integral v du.
Yeah.
Now, when it's a definite integral, you end up evaluating the uv. So it's minus x cosine x evaluated from 0 to pi minus integral v du. So that minus goes with the plus cosine x dx again from 0 to pi.
Um, is that it?
Well, you got to keep going. You have to be able to integrate cosine x. So what is the integral of cosine x?
The sine X?
Sine x, you're valued from 0 to pi minus x cosine x from 0 to pi. So you just have to be able to evaluate here. If you're allowed to use a calculator, I mean, I don't know. That's what I understand, because if you're allowed to use a calculator, I don't even know why you would do any of this. You would just put it in the calculator. I'm
Um,
not sure, but nevertheless, you're minus pi cosine pi minus 0 plus sine pi minus sine 0. These all go away, and so you're left with cosine of pi is -1. You're left with just pi. That's your final answer. Any questions, thoughts on that?
okay. No, I'm good.
All right. Part B, find the solid that is generated when the region A is rotated about the x-axis. So again, like we don't know what it looks like. Maybe we'll figure it out, but you're rotating about the x-axis. Is this a disk or a washer problem?
Uh,
And do you remember how to tell the
this,
difference? It's a
this.
disk. Yeah, so I always show it this way: integral pi r squared dx. R is really a function of x. So in this problem here, it's pi integral 0 to pi. Your radius is the y. It's the x sine x. So it's x sine x squared dx. So I don't know. I guess I don't know why you wouldn't just go right to your calculator here. Do you know? I mean,
Yeah. Okay, then if we can just use our calculator, then I'll be fine.
I'm not sure. It depends if they want it
It says
exact or not.
calculator on it, so
Right. Like what I remember is that you could use the calculator, you could do it by hand, but I don't know why you would. You just use the calculator. This one's very difficult to do. It's integration by parts with a trig substitution um, for a double angle. Kind of a messy thing, but it can be done. It absolutely can be done. All right. Any any other questions before we move to part C?
no.
Okay. All right. Find the volume of the solid when the region is rotated about the y-axis. So this one's more challenging. It's the same, you know, region here, but this time we're going around the y-axis. So there's a couple of options here. One is to try to do a washer method, but what is the requirement for that? What do we have to do to this on the right here?
I'm gonna change it.
You have to solve for x, and that's almost impossible to do. So that's out. What is the other way to do this integral, if you recall?
Um, I don't know.
Did you guys talk about the shell method?
Oh, yeah.
Okay, so this is a shell method problem. If you don't know that, I mean, you can just never do it. So the integral, nice thing is it's in terms of x. It's 2 pi y, which is really your x. I'm sorry, 2 pi x, and then your function, which is x sine. Does that look at all familiar to you?
Yeah. Sorry, I haven't
Okay,
done that in a while.
right. And again, that can go into the calculator unless you got it by hand. This one can be done by hand. It's integration by parts twice. You know that because it's x squared. I mean, maybe that's why it's a calculator problem.
It's okay. I can just use my calculator. We can move on to the next one.
Okay. All right. So let's see. Number 4, BC only. It's another calculator problem. All right.
All of these, I think, are BC problems.
All right. So for 0 to 2, a particle moves along the x-axis. The velocity of the particle at time is given by this function. At a time t equals 0, the particle is at position x equals 2. Find the particle's position at time t equals 2 using integration by parts. Okay, any idea how to set this up?
I'm just copying it down. Mm, we just do the integral.
Well, it's actually the fundamental theorem of calculus. It's that the you have the initial position, which is 2, plus the integral from 0 to 2. The 2 because of that initial position. Then it's the integral from 0 to 2 te to the minus t over 3 minus 1/2 dt. And so again, like, I don't know why you would do this by hand. I know it says to use integration by parts, but like, why wouldn't you just use a calculator for this? I'm asking you because I have no idea.
Oh, it says calculator, so I assume we can just use one. I guess if it says that, then I assume we can.
I mean, this is where you gotta, you know your teacher, you know what they're expecting.
Well, if it
Uh,
says calculator, I assume we can use our calculator.
right. Okay.
Okay, then we can just move on.
Okay. So that's the position. All right. The part B says to write, but do not evaluate. Write, but do not evaluate. Let me get the snip of that.
What'd you say?
All right, I'm just grabbing a snip here. It says write, but do not evaluate involving one or more integrals, which gives the particle's total distance traveled from time 0 to time t equals 2. Why do you think it's saying to one or more integrals? What do you think's implied there?
Um, like I would just separate them out.
Yeah, but why? Why do you think they're suggesting that you separate them?
Um, because I'm not sure.
Okay. So they're very good in like they're trying to help you out here. They really are. Like they're not They're not being difficult, in my opinion. If you were to graph this thing from 0 to 2, which I've done here, does this help kind of answer that question, like why there might be two integrals?
Yeah,
Okay, why would there be two? Give me that in your own
because there's
words.
like two different like areas under the curve.
That's right. There's a negative area, which means the particle's going left, and there's a positive area where it's going right. And the total distance, it includes, the positives are positive, and you can negate the negatives, basically, make them positive. All right. So how do you figure out where, like, I know it's 0.613, but um if you couldn't graph this, how would you figure out where it crosses the x-axis? I mean, what are you effectively doing?
You could like look at it on a calculator.
Well, you're setting this equal to zero, this function equal to zero, and yeah, you're graphing it. Okay, so there's two integrals. There's the integral from 0 to 0.613, and it's negative. It's negative because it's the area is below the x-axis. So the area is negative, and we're integrating this function here, this te to the minus t over 3 dt. And then we're adding the integral from 0.613 to 2, te to the minus t over 3 minus 1/2 dt. And usually that's acceptable. Is that okay for you?
Yeah, wait, can you just leave it there for a
Yep.
second?
Yep.
Okay,
Got it all?
yeah.
Yeah. Now Part C says to find the particle's acceleration at time t. Uh, so how do we do that from the velocity function? What's the relationship between velocity and acceleration?
Um, the derivative.
Yes. So could you take a derivative of v of t for me, please? It's a product rule
Wait
derivative.
one sec. Wait, how? Wait, can we do this one together?
The product rule is fg becomes f prime g plus fg prime. Does that help? And you're splitting it right there.
Yeah, but wait. So then it would be like, wait, would it just be e to the negative t over 3 plus, actually minus 1/3 t e to the negative t over there.
Very good. Okay. So that is the acceleration as a function of time. So that is part one, kind of. Now it says, is the speed increasing or decreasing at time t equals 3? So here's how you know. Um, it's basically asking, is it speeding up or slowing down? So if v prime, sorry, not v prime, if v of 3 and a of 3 are in the same direction, like either they're both positive or both negative, it's speeding up or increasing, you could say. And if v of 3 and a of 3 are in opposite directions, like one's positive and one's negative, then it's slowing down. So you have to calculate v of 3 and a of 3. So it's up to you if you want to calculate that, but that is what's required here. I mean, I would grab a calculator and do it right
Wait.
now.
So you make but how do you find
You
that?
have the velocity functions, you put 3 in for t, and you have the acceleration function, you put 3 in for t.
Oh, I don't have a calculator nearby.
Okay, well, I'll direct you to one on the internet that I really like here. I do recommend you do this, but uh, yeah, that's up to you. Um, it will help to get the answer, and definitely would have a calculator available for it. I mean, you're gonna have one on the AP, so you might as well have them when we're doing our lessons.
Okay, so v of 3 is 0.603.
So it's greater than 0. We actually don't care what the numbers, just care whether it's positive or negative.
And then wait, I got a of 3 is 0 exactly.
That is true. Let me check your derivative here. Check that. Um, yeah. Okay. So uh, there. So it's neither. I mean, if the acceleration is 0, which let me go ahead and look at the graph one more time. Let me go out to 4. Yeah, so it actually does have a horizontal tangent there at so it's neither. So it actually just has constant velocity. When you have constant velocity, there is no acceleration. So maybe call that a trick question if you want.
So there's no acceleration.
Yeah, I mean, if the acceleration is 0, then it's not accelerating. It's just like when you're on the interstate at a constant speed, you're not accelerating. You're just moving at the same speed.
Okay, so what do I say?
Any of those words that it's constant velocity, there's no acceleration. It's neither increasing nor decreasing.
Okay.
All right, ready to move on to number 5 or not? Let me
Hello.
know if we can move on to when we can
Oh,
move on
yeah,
to number
yeah,
5.
yeah. Sorry.
Okay, right. So new problem here. They give you a table, whatever that's, F prime, G prime, some values here. And they're giving you this thing. You're like, okay, they're great. But they want you to find this. All right. And without being told, this is integration by parts. I mean, I don't know how you would know if someone doesn't tell you. So you look at this, you're like, well, which do I make U and which do I make dV? Well, you need to be able to take a derivative. So U is f of x and dV is G prime of x. And the reason is you don't have like the antiderivative of f of x. You don't have like big F of x or something. Um, the reason this isn't G of x is 'cause you don't have the second derivative of G of x. So you have to like do the thing that they have, which is okay, du or u prime is f prime of x dx, and v is g of x like that.
Okay.
And I don't know if this is like, I don't know if I haven't seen the BC exam very often, but like it seems like integration by parts is all over the place. So that would be a good thing to review if you know, have some time, want to get caught up on stuff. So formula here is u v minus integral v du. So that's f of x times g of x evaluated from 1 to 2 minus integral uh, f uh, uh, g of x f prime of x dx. But now all of a sudden you're like, oh, now I know why they're giving me this initial part here. This part over here is 3. How would you evaluate something like this on the left? What do you see?
Wait, I'm sorry. I'm still copying.
Sure. Yeah, go ahead and get caught up.
Um, would you do like what you just did again?
We've already found like and there's no calculus here. This is more of just like how do
Oh, but that's
you
the thing you already saw. Wait. So what are you saying?
I'm asking you what to do here. Like how do
Would
you
you just
think
plug in the two and then the one and subtract them?
exactly? So you got to go back to your table. F of 2, G of 2. Looks like it's 2 and 3. F of 1, 3 and -1. You might double check that.
Wait, so it would be wait, just six?
Uh, well, it
Wait,
looks like this is +3. Yeah, it looks like it's just 6, which hopefully is one of the answers. It is. Any thoughts on that or concerns or any follow-up?
No.
All right. We might get through all these. The next few are going a little faster. Um, right. Next problem here, 6A, show that f is continuous at 0. To do that, you have to evaluate the each function at 0. So you gotta figure out what 3 plus 4 times 0 over 1 plus 0 squared, and show that that's equal to tangent squared of 0 plus 3. That's for continuous. Nothing to do with calculus, actually. So do you agree here that these are the same? The left is the same as the right?
Yeah.
All right. So now f of x in part B is asking for a derivative. So this is where, they sure didn't make it very easy on you. What's the derivative rule for the top one? What would you do here
Wait, what was the question asking?
for the derivative?
Um, you have to use a quotient rule.
Yeah, yeah. So could be a bit of a messy thing there. Do you do you have some questions about the derivative of that? Do you want me to write it out? What would help you here?
Wait, let me just do
You don't have to simplify, you gotta have it there.
it. And then would it be like
Doesn't say
secant to the fourth or wait?
that again for the
Would it
bottom
be
or
like
the top.
2 tan x secant squared x?
Yeah, 2 tan x gets the derivative of that. Then you gotta take the tangent. Tangent is secant squared x. And there you got it. Okay, great. Now you don't have to simplify, but you you do have to find it. All right. Who writes these questions? These are so it's just they're not connected in any way. All right, average value. That's -2 to 1, it looks like. That look Just making sure not missing a negative sign or something. Take that as a no. So the average value of an integral is 1 over b minus a from a to b f of x dx. Problem here is that the breakpoint in the piecewise function is at 0, which means you have to find the average value from -2 to 0, and then from 0 to 1. So it's 1/2 the integral from -2 to 0, 3 plus 4x over 1 plus x squared dx, plus 1 over 1 integral -1, 0 to 1, tangent squared x plus 3 dx. And these are both calculator problems, which means just put it in the calculator. Is that okay?
Yeah. Then we can move on.
Number 7. All right. No calculator. Oh, you know what? The previous problem had no calculator, by the way. I mean, that's pretty rough. Um, you know what? That what I gave you is wrong. That's not how to find the average value. Um, so uh, this would be true if we were doing the derivative, which we don't have to do. So actually, there's actually way less work to do here. Um, this is all wrong. You don't need this for average value. You do if you're using integral. So it's the average rate of change. This isn't even calculus. It's f of b minus f of a over b minus a. So none of this is applicable. It's f of 1 minus f of minus 2 over 1 minus a minus 2. So you just gotta you just put this in to the function here. So like, and they're actually putting them into this one for 1, and then the other one for 2, -2.
Wait, so is that the right way?
Yes. The average value is integrating the original, integrating the derivative, which is not what they gave you. So f of 1 is tangent squared of 1 plus 3, whatever that is. F of -2 is 3 minus 8 over 1 plus 5, which is -5 over 6. So it's whatever that is. Tangent squared of 1 plus 3 plus 5 over 6 over 3. And I believe you can leave it unsimplified like that on the AP.
Okay.
All right, now we can go to 7. I guess I got to pay attention. So no calculator. Find the particular solution of this differential equation, T in terms of R. Okay, so this is a partial fractions problem. Have you been studying those?
Yeah.
Okay, so you got to be able to break this thing apart. Um, how have you guys been doing that in class?
It's like, yeah, plus B 5 minus R.
Okay. Now what are you guys doing now?
Then we like do this would be like A times 5 minus R times plus B 2R. So it's like,
Okay, so you're just doing the standard, yeah, that's fine. So you get 5a minus 5r plus 2rb, and you've got, sorry, I'm very tired. This is wrong. Um, you've got, this is 1, and it's 0r plus 1. So 0 equals minus 5r. No, that's not right. Um, plus 2rb. Why am I struggling here? And then one equals 1 is equal to 5a. That doesn't look right. All right. Well, so the answer here is you got to break this apart. 5a minus, oh, that's why. Whoops. 5ar. That's why we're struggling. Okay. There's the problem. Ah, boy. All right. Sorry about that. You got to multiply them both. 5a minus ar plus 2rb. And so you set the ones with r equal to 0. So minus a plus 2b equals to 0. And then 1 equals 5a. And then you solve them. So a is 1/5. b is equal to minus a or positive a over 2, which ends up being 1/10. Right. And so after you get this, you can then integrate the original function here. So you got 1/5 over 2r plus 1/10 over 5 minus r dr, and then capital R. Oh, I would switch to lowercase. And then integral dt on the left. Does this look familiar at all?
Yeah.
All right. So on the other like little change here is that this is really a 1/10 over r plus 1/10 over 5 minus r. So when you integrate on the right, on the left, you just get t. T is a function of r, big R. On the right, it's 1/10 natural log absolute value of r plus 1/10 natural log absolute 5 minus r, but then there's a negative in front because of the fact that it's negative there, plus c. Any thoughts on that?
Okay.
Any concerns? I mean, you know,
Yeah, that's good.
okay. There's the last little piece here, which is to find the constant of integration. It says it says that when r is 3, p equals 0. So you got 0 equals 1 over 10. Natural log absolute value of 3 minus 1 over 10 natural log absolute value of 5 minus 3 plus c. So there's a bit more to do here. You can you can combine the logarithms. This becomes natural log of 2. This is natural log of 3. You can factor out the 1/10 from both of those. And then you've got difference here. So it becomes natural log of 3 over 2, 1 over 10. And then you move that to the other side of the equation, ends up being negative there.
Okay.
So that would go back in. And you're back into the original here.
Mhm.
Okay, part B. There's always more. So part B says find the R values for the inflection points. How do we do that from the derivative? We're given the derivative, the differential equation here. How do you get inflection points? Which derivative do you look at?
Um, when like the second.
Second derivative. So we've got the first derivative, which means you have to take a second derivative here. So what rule are you going to use to find this derivative?
Um, quotient.
You can also use the fact that we actually rewrote it here. And that might make this a lot easier to take the derivative of. So do you still want to use quotient rule for this?
Yes.
Okay, it might be better to use power rule
Okay.
because then there's less stuff. So I've not taken a derivative yet. Okay. Um, so do you want to try taking a derivative of this for us, please?
Wait. So would it be like negative 1/2R?
Right. Remember, you're subtracting one, take a derivative, so it becomes r squared.
Or would it be like 20R?
Nope. You're just bringing that negative one down, subtracting two, subtracting one to make two, negative two, which goes to the bottom. Like at a minimum, you should be able to get this minus 1/10 r to the minus 2 power, but it really goes to the bottom. Could be useful. And then this becomes minus 1/10, 5 minus r to the minus 2 power times negative 1, which makes a plus. So your second derivative here is minus 1/10 r squared plus 1/10 5 minus r squared, like that. And then you're setting this equal to 0 to find inflection points. Any idea, remember how to solve something like this? So first thing is that r cannot be 0, r cannot be 5 because you can't divide by 0. If you add this term to the other side of the equation, you end up getting 1/10 5 minus r squared equals 1/10 r squared. You can then cross multiply 10 r squared equals 10 5 minus r squared. The tens cancel. So you got r squared equals 25 minus 10r plus r squared. Those cancel, and you get r equals 25/10 or 2.5. Then you should make a sign chart because you don't even know if this is a critical point. May not be. And then you would make sure to include those values that are not allowed, 0 and 5. And you'd want to test something like 1 and maybe 3, but you have to test it in the second derivative. All right, so you're going back to, this right here. This is where it gets a little clumsy for most students, especially when you don't have a calculator. It's like, oh, what do I do? When you put 1 in, negative 1/10 times 1 squared, you get negative 1/10 plus 1/1 there becomes 1/40. And so, which is bigger? Negative 1/10 is bigger. So this is negative. And we got to try it at 3. You get negative 1/90 plus 1/5 minus 3 is 2 squared, 4, 1/40. This time it's positive, and looky there, it is an inflection point. You could have just said that, but you wouldn't be showing or proving it, verifying it, whatever. All right, so probably don't have enough time to do 8, but I'll give you some uh, encouragement here. Appears to be a L'Hopital's rule problem. You might just take the derivative anyway. Negative 5e, the 1 minus x minus 1 over x. And then this time it probably worked. You probably get negative 5 minus 1 over 2, which is negative 3. It's probably the easiest one on there. All right, that is going to do it for us for tonight. I will definitely send you the notes here in the next few minutes.